Hello class. This will be our final lecture, I think, for this semester. And I wanted to give you some thoughts on emerging healthcare IT technologies and topics that we just didn't cover in depth in the course because of the compressed time and the fact that, well, healthcare changes, IT changes quickly, I should say. The pace of technology moves so quick, even in healthcare, and we're notoriously slower than much other industries for sure. But I at least want to close out the lectures thinking about kind of what's current, what's happening, what are some trends, and hopefully you can carry that forward and use that as information to augment what you've already learned. These videos and any kind of information on technology, it's inherently dated. So everything I'm giving you is current, more or less, as of the fall of 2021. Watch this video next year, 2 years, 3 years from now, everything's going to change, or at least be different, the current topics anyway. But let's start out with the concept of truly sharing medical records. This was the promise that EHR's electronic healthcare record systems brought to us when we scanned in the paper documents and put them into databases, and then made systems dedicated to the collection of patient, demographic, and clinical information, and then financial information to ultimately better serve the patients. Naively, the government and healthcare providers, industry in general, everybody thought, hey, the records are electronic. We can share. It's automatic. No, it's not automatic, and we have seen what has not happened. There has not been any real sharing of electronic records, and it's unfortunate. But the last two administrations in America have both worked on legislation and enacted the 21st Century's Cures Act, which, among many things, includes price transparency. We're not going to talk about that today, but essentially it's just having the prices of any common procedure available on an easy-to-find web page, web link, right off of the hospital's websites, the providers' websites. So that's a great step forward into consumerizing healthcare, but we'll save that topic for another day. What I really want to talk about are the rules and regulations to share the medical records, and that's referred to as the final rule that came out from ONC just about a year ago, that it was officially signed and put into motion. Now, both CMS and ONC have worked on these regulations, and it's taken a long time for us to get here. But what it means essentially is that providers now must, and technology vendors, must provide patient access electronically, including cell phones, smartphones, electronically to the medical records. And that's called interoperability. The providers have to be able to share information together between one EHR to another. And they also are prohibited by law from blocking that information. And you might have heard some of this referred to as anti-blocking. Nonetheless, this applies to all players in industry. The providers, the technology vendors, and the payers. Everyone must have their systems open and shareable so patients can access their records. If you think about it, this has gone to really revolutionize the request of information process, the ROI process at almost every organization, and that industry will change. Because I suspect the bulk of patient record requests will ultimately come through this final rule electronic mechanism rather than the paper and fax and hard copies that we're accustomed to. And the cool thing about this interoperability is that patient-generated health data can also be included in what's shared. So imagine our walks, our eating habits, how much sleep we get, those daily vitals, and any other information that we input into our applications can possibly be shared with our providers to be included in our healthcare records to give us a much more complete longitudinal record. Now that's pretty cool. This word interoperability, what does it really mean? Well, if you think about it, or maybe you don't think about it because you might not be aware of the history of computing, but when computers were originally developed, they didn't talk to each other. They used completely different technologies. Well, first off, the first computers weren't even networked. But let's assume we get to the stage where they were networked. Every single computer vendor, or most, had their own proprietary networks. So you could not plug an IBM machine up to a Hitachi machine, up to a machine from Digital Equipment. It was not possible back then. And then the supercomputers used their own high-speed networks. All that changed when we started to standardize the networking technology. We went to what we now know as you see those little telephone-like cords, the Cat5, that suite of technologies around electronically passing information over wire. And now, of course, we have wireless, but it's all related. Until we brought that technology, that standardization into industry, the computing industry, computers could not even talk to each other unless they were the same brand. Does that sound familiar? Epic only talks to their Epic boxes, their MyChart and the community systems. Cerner only talks to their extended networks and so forth. It's the exact same thing repeating itself over and over again in an effort to try to make information shareable, but only within the vendor's silo. And that's what the 21st Century Cures Act, the final rule, is now prohibiting. Epic cannot just have all of their information available only for Epic EHRs. Same thing for Cerner and every other EHR vendor. And hospitals can't stand behind and say, oh, my EHRs don't share information. That doesn't work anymore. The new laws, the new regulations impose significant fines, up to $1 million, at least for the vendor case, for instances where their systems are found not to be open to share information with the patients, their data, to share that information with all the providers that the patient requests them to share. So it's an interesting new world, and that's an evolving topic that I wish we had time to cover in class, but now at least you have a little bit of information on it. The next big topic I want to talk about is really the military, if you can indulge me for a second. It's early morning here. So the DARPA, Defense Advanced Research Projects Agency, is the organization that actually created the internet. The internet is much, much older than the web. The web's built on top of the internet, which is built on top of the networking technologies we talked about a while ago. But that technology itself, the networking protocols, the ability for computers to talk back and forth, was invented by our U.S. military under this agency called DARPA. And if you're not familiar with DARPA, it's a fascinating agency. It's probably the most efficient agency other than the IRS when they're trying to collect money. It's the most efficient agency that we have in American government. Think about some of the technologies that DARPA has created, if you're not familiar. GPS, what we use for navigation in our cars, on our phones, on our watches, and all kinds of related things of that nature. That was invented by DARPA. If you've seen the Boston Robotics dog, that's amazing piece of engineering and artificial intelligence, that was invented by DARPA contracts. The very computer technology you're using, the graphical user interface, to have windows all over the place and a mouse to navigate, invented by DARPA. Even some of the technologies that we invent are put to, let's say, unexpected use. And the United States government, DARPA, our military, invented the core technology of the dark web. And if you're not familiar with the dark web, that's where you can do pretty much you can buy anything and see anything that you want. It's a very dangerous, sundry place, but nonetheless, it's out there. It's where the medical data, for example, when it's stolen, from hacked systems, it's where all that information about all the patients are taken and stored on the dark web, and then ultimately sold. And that technology around the dark web was called onion routing. That really obfuscates where you're coming from and where the servers are located. Every layer of the onion is encrypted and randomly routed, so no one can trace where the servers are and where the people on the servers are coming from. That was a U.S. Navy DARPA project. So we have ourselves to blame for some of this stuff. Even the technology in Siri, when I pick up the iPhone and I say, Siri, find the address for so-and-so. That technology also came from DARPA. I'm not even beginning to scratch the surface of it, but these are the most common, well-known applications. So DARPA is very, very famous in my world. I live in Washington, D.C. area, and my technology world, as a very, very influential agency that does great, great things. And why am I talking about DARPA? Other than the fact that DARPA actually funded the research, believe it or not, for the mRNA technologies that was used to help bring out the COVID vaccine very quickly. That was also a DARPA thing. But why am I talking about it? Well, it's interesting that, let's say, the success of DARPA is widely respected in other countries as well as United States. And now there's many ARPAs of everything. And Health ARPA is coming to us soon, I think. This year, 2022 government fiscal budget, they're looking at, the Biden administration has put a $6.5 billion request in to have a Health ARPA. It's referred to as ARPA-H. And that's going to reside inside the National Institutes of Health, actually not too far from me in Bethesda, Maryland. And this ARPA-H will be charted with solving the difficult problems, just like DARPA did for technology in military applications that ultimately found their way to consumer applications. ARPA-H is going to do the same thing, intended to do the same thing, but for healthcare technologies and genetic research and all kind of core technologies that will ultimately make their way to the healthcare treatment system. And I suspect other technologies that we can't even think of. Maybe some of this related to the information blocking that is coming out from the final rule. What kind of applications, what kind of new ideas will we come up with for the smartphones that can do something intelligent with our data, perhaps? So that's Health ARPA coming, and that's pretty exciting. So I'm really interested to see how that goes. And finally, I want to talk about artificial intelligence. This is trending in our industry, healthcare, very, very broadly. There's not a single hospital that I've spoken to over the past year that doesn't have some kind of plans for AI, if not already had something in place. So the first area of AI, we're just going to talk about two. The first area in AI that I think of is robotic process automation, RPA. And RPA has been around for a long, long time in some form, because it's like the older versions of screen scraping, where that technology was invented for the visually impaired or blind users who couldn't navigate a graphical user interface. We talked about that earlier. So screen scrapers would read what's on the screen, interpret what's on the screen, and then read it back to the user. And that technology advanced, and now we're actually at this process where we can automate processes that we do manually, repetitively, and that's why we call it robotic process automation, RPA. It's a way to increase productivity, to automate routine tasks, and to really just enrich the jobs or reduce the repetitive nature of many jobs in healthcare and other industries. True to form, we're just adopting it now, but RPA has been around other industries for a while. But it does employ some interesting uses of artificial intelligence. We use optical character recognition to read a graphical user interface, so then we can send it to a natural language processor, NLP. We've read about all of these in our text. And as we read what's on the screen, we can do some smart things. For instance, if we're processing claims, we can go through and read, see what the issues are before we submit, or work on the denials. RPA is very, very focused on these kind of value-added solutions. In my world, for patient matching, my day job, we can use RPA to actually process queues of related patients and then go merge them in the EHRs, for example, or do research, bring together information from external sources like TransUnion and other commercial credit databases to fill in medical records that need more information. We can automate all that with RPA. And the real goal, I think, is to reduce human error, reduce cost, and it's everything you can think of robotics in electronic industry, the automobile industry. It improves the quality of the product while also ultimately reducing the cost of manufacturing. Those similar economies of scale are going to come through the use of RPAs. It's very, very fascinating. And lastly, I want to close on talking about bias, health inequities. It's a very, very common, I'm saying very loud, I'm sorry, today. It's a common topic that we hear about. I just came back from HIMSS a couple months ago, and that is a topic that was a lot of presentations, social determinants of health, SDOH, as well as health inequities. And our healthcare systems reinforce those things inadvertently through technology. And so what do I mean by this? Well, there's a bias in algorithms, whether it's artificial intelligence or not, but there's still a bias in algorithms. And that comes essentially from the data that we input into the algorithms. I can give you an example. When we do patient matching using machine learning to learn if two patient records are the same, we can compare them eyeball to eyeball, and humans can recognize if the records are related or not. That's exactly what we use. That information is exactly what we use to train artificial intelligence systems. Well, what we find is that looking at the training data and doing analysis, which fields are mostly related, most prevalent to identical records, and it's always the database. I'm sorry, the date of birth. It's always the date of birth. And that reinforces, the training data that we use reinforces the belief that a lot of humans have, is the date of birth must be exact, everything else can vary. And we see that a lot in patient record matching, in registration and HIM departments. But I'm here to assure you the date of birth has as many errors in the column as first name, last name, address, and so forth. But the data biases that we bring from the human reviewing the forms or the records, it's inherited by the machine learning patient matching algorithms. And the same thing is true with other areas of healthcare. There have been studies shown, for example, that patients of color do not get pain medicine at the same percentage as Caucasian patients. And that's perplexing, but it's something we've studied and we've learned. And that's part of the health inequity conversation. But the question is, the concern is, we have this clinical data and we have different characteristics of patients. Sometimes we're talking about blood types, height, weight, allergies, medicine list, and race. We have all of these attributes of a patient. And when we train systems that have these inherent biases in the data, we produce flawed algorithms or biased algorithms that carry those flaws or those biases forward. So we have to be really mindful of this, and it's a very here I go very again. It's a hot topic today. How do we reduce or eliminate algorithm bias in healthcare applications as we try to make healthcare more equitable and perfect our systems? We've got a long way to go, but it's an interesting topic of discussion. So that's my hot topics for today. Try to keep this under a half an hour for the semester, at least. Hot topics. Next semester, next year, it'll be different. But I hope you enjoyed learning just a little bit about what's going on in healthcare IT, informatics, and technology outside of the course. Thanks so much for listening, and have a great day, guys. Bye-bye.